a lot of you know me, so I won't even go into the details, but how many people have gotten into an accident? Serious accident in your car? All right, so there's some videos here. If you're gonna have PTSD, if I show the videos, just raise your hand and I'll stop the video. So we're gonna talk a little bit about fire service and safety. And the reason I got into this is, in fact, I'll go a little bit through my bio. You could go through my bio, but the realistic part of it is I was a geek and I was an introvert. And that was probably all through high school. Whoops, that didn't show. So much for the Mac. So I was a geek. I was in high school and really didn't get involved in anything. I come from a really large Italian family, 6 boys and 1 girl. And I'm proud to say I'm the only boy in my family without an arrest record. And part of the reason was because in high school, someone actually got me involved in the local fire department, local volunteer fire department, where that was my hangout. And part of that became 40 years as a volunteer firefighter, on top of my parallel career as a cybersecurity and tech guy. And eventually, for the past 13 years, I've been a fire instructor. And actually, I teach vehicle extrication along with some other classes. But this was kind of near and dear to my heart. So I kind of wear 2 hats. I wear the cybersecurity hat or the tech hat, and I also wear the firefighter hat. And this idea came out of some thoughts I had when I was teaching extrication and some of the accidents that have happened lately. Before we even get started, I want to just go through some terms because you'll hear them over and over. DBW, or drive-by-wire, is basically the method that's actually used in planes these days. It's electronic systems. So basically, when you go to turn the steering wheel, right, it's actually sending an electrical signal to the steering component or steering actuator. So it's not really a direct connection anymore. In planes, they use this because what they do is they have redundant systems, redundant electrical drive-by-wire systems. That's where it came from. The next is something called the Controller Area Network, or CanBus. It's basically the network that's used inside of planes, cars, any type of vehicles. And then the third is drive-by command. So drive-by command is basically changes the way drive-by-wire works. Instead of having direct wired connections between the steering and the actuator that turns the wheels, there's a central network, CanBus, and you send a command to the CanBus controller, which sends it to the actuator, and then the actuator will turn the wheels for you. So it's kind of a level of indirection. If you think about infrastructure as code, this is infrastructure as code. So drive-by command. It's not to be confused with another DBC, drive-by cable, which was the really old way of doing things. Everyone understand that? Okay, cool. So this is what a DBC example looks like. Every car manufacturer has their own DBC definitions. So there's no standardization in the industry about drive-by command. And so here you see, the engine speed, which actually would be the this ID right here, and that ID might be brakes on another car. So again, every DBC is different, and that's one of the downfalls of having this drive-by command, is that you can't interchange systems. But how many people have cars where they modified the efficiency on the car using software updates? Right? That's kind of what happens, is that you end up putting in different commands into the DBC configuration file. So, and again, when you get into this area of modern cars and everything being DBC, we've seen a lot of hackers, right? We started showing Chris Roberts with the airplane, right? The navigation system in the airplane connected to the entertainment system. Again, don't know how true that is. Actually had Chris Roberts come to speak at our very first conference in 2014, and he was actually denied the access to the plane, to get on the plane. So he never spoke. We also saw back in 2015, the Jeep that was controlled, right, remotely, right? Again, that was one of the very first areas of CanBus exploits being used. More recently, though, we saw this CanBus access through the headlight port. I give them a lot of credit for being very innovative, but if they were smart about cars, they know that the headlight leveler is actually under the rear axle. And you can actually you don't have to break into the car or break the headlight of the car to do it. You can just basically slide under the rear axle and put the new sensor there. And basically the way that works is it emulates another actuator and fools the CanBus system into believing that it's the anti-lock system or anti-theft system. And of course, this I think I pulled up the other day, over 16 car makers have similar problems. with the CanBus. And we'll talk about CanBus encryption a little bit later on. So I'll put my firefighter's hat on. I said, you have all these hackers using CanBus to do all these crazy things, change the steering, break the system. Why can't we do that as a firefighter? Why can't I do that to help the system, to help me rescue people who are trapped? And I'll go through a little bit on what extrication is. Any firefighters here? There's only one, see? All right, so I'll just give you an idea of what auto extrication is. Do we have the sound on this? No, of course, sound does not work. That's fine. We could talk to it, but basically, it's the whole purpose of auto extrication is to rescue people. As a firefighter, the rule of thumb is you always leave a scene or a situation better than when you arrive. And that falls down to three things. Basically, protect people, protect lives, and then protect property, right? So the problem with extrication is that it's dangerous to both you and me. So in this particular case, actually, we just had this in Rockland County last year. We had a Tesla that caught fire. The driver could not get out because the Tesla had electronic door handles, right? You touch it and it opens up. But when the car was compromised, right, the electrical system didn't work. And the manual door handles, which is required by NHTSA, was actually under a panel under the armrest. Now, if you're in a panic and there's flames at your feet, are you going to remember that? Are you going to remember, oh crap, did I look at the safety manual and find out where that manual handle was? You got a question? No. All right, so so this happens actually more often than not, and it's been happening more and more with the EVs. But even with regular cars, a lot of the newer cars don't even have manual door handles anymore. They all have electric door handles. From a firefighter perspective, this happened again 3 years ago. FDNY guy goes to help someone out of an extrication, and he's on one side of the car, but he needs to get to the other side of the car to access the person. And on the other side of the car was a space between the bridge. You can see that up top, right there. And he fell through that space. So again, his access was just really, really detrimental. Airbags. So basically accessing a rescuer accessing your car, even after a crash, the airbag goes off. It's not pleasant. It's like a brick wall. In fact, anybody know what the seatbelt pretensioner, when you get into an accident, the seatbelt actually has electronics that pull it tight. Do you know why it's pulling you tight? So you don't hit the airbag while it's inflating. It's pulling you back in your seat. So that way, when you hit the airbag is actually deflating. That's how it absorbs the shock. You hit it when it's deflating, and then that's when it makes you safe. If you hit it while it's inflating, you're going to have issues. And then finally, the fob-based vehicles. They were at an accident in the FDNY last year, and this vehicle just rolled over because the fob was close to the ignition, and it leaned on a piece of, I guess the driver's side leaned on it, and it started the car up and had the car rolling. Firefighter was okay. He broke his leg in 2 places. But again, we can prevent all that. That's all preventable stuff. So I want to talk about the way firefighters think. Just like your SOC teams, we have a playbook. And our playbook consists of 3 things. The process. Our process is, number 1, stabilize the vehicle. Number 2, get EMS access to the vehicle, right? Get access to the patient. And number 3, then we worry about taking the patient out, egress. So stabilization, access to egress. And a lot of this conversation following this will flow with that. Next, we also prepare for the unexpected, right? If the fires happen on an accident, I was just saying earlier, in the old outside of the Pinto, which used to, blow up when you rear-ended it. A lot of people maybe not remember that. But a lot of cars didn't really catch fire when they were in an accident. Why? Because you had a heavy frame. It was a metal frame. The gas tank, fuel tank was actually pretty well situated within that frame. With modern cars, we have crash zones, right? And they're made to collapse. Well, what's in the rear collapse area? Fuel tank. So a lot of times we get more fires now with accidents than we did before. And that's something to remember. So we always have to worry about that. And exigency measures basically means that if a life is involved, right, let's forget about the stabilize, access, and egress. Just pull the sucker out as quick as you can. And that's kind of, again, we always have that in the back of our mind, and we actually practice that, because the more you practice, the more it becomes routine. Yes? Muscle memory. And finally, we always show up at a scene. We always have a plan A. What looks good at the surface may not be the case, so we have a plan B. And maybe we have some issues with tools, or maybe we have issues with the positioning of the vehicle. We have plan C. We keep going plan after plan. The way I teach extrication is I give each team of 4 people 30 seconds to operate. And after 30 seconds, they have to step away and the next team comes in. Kind of trains them to observe, see what's going on, and do they continue that tactic or do they try a different tactic? Again, the way we work is we have to constantly follow this. And again, if you guys are in SOC teams, you kind of do the same thing, right? From a cyber world. So this is a pretty long video, but basically shows all those different aspects. I'll talk through it because sound's not working. But if any of you feel quizzy, just raise your hand and I'll stop the video. So in this case, we have a car into a tractor trailer. The driver, there was only the driver in the car, and he's trapped. So the dashboard came, when he hit the back of the truck, the dashboard comes down onto his legs and traps him in. So we really can't get him out at this point. What makes this a little more difficult is the tractor trailer itself caught fire. So we have the contents of the tractor trailer that are on fire, and we have to manage that as well. The other issue that happens is when a car goes into the back of a tractor trailer, it gets pushed down, right? So the suspension gets compressed, meaning that it's basically jammed in there. There's really no way to just pull it out and try and get to it unless we do something called capturing the suspension. So there's a fire in the back of the truck. So we have to handle fire control. We have to figure out, we have to have a whole crew that does that. That's at least 2 to 3 people. So 2 people on the hose line, 1 person for safety. At the scene, we actually have usually 1 person with the patient and then 1 person for safety. Then for the extrication or the access component of cutting doors off, we have at least 2 people with the operations of the tools and 1 person for safety. So you see how the amount of resources adds up. Can we cut this down? And again, this video's it's spliced. This operation was about an hour and a half long. So we cut it down to basically 4 minutes. But you see all the things that are happening. We have saws out, we have hoses out, we have extrication tools out, meaning cutters and spreaders. We actually at one point brought in a rig with a winch and tried to winch the truck out once we captured the suspension. And that I think we'll show that in a little bit here. But that didn't work. So we had another plan to go and get a heavy tow. There's the rig with the winch in the front. And I think once they capture the suspension, which means they hold the springs tight, they're going to try and pull that truck out just to give them a little more room, right? They can't expand the dashboard until they take the truck off of it. Victim is alert. He was not talking. One of the things you learn in extrication is that when something's painful, people scream. When it's really painful, they're quiet. So just kind of things you see. And actually, while we're looking at this, I'll tell you, I've been a firefighter for 40 years. I probably remember maybe 3 or 4 of the big fires I've been to, but I remember every extrication I've been to. I remember every face, every accident, every person. Anybody know what this tool is? Yes? No? It's called a Halligan. This is about 20 pounds. You want to feel it? It's maybe 20, 25 pounds. Pretty heavy duty tool, right? This is the all-purpose tool for extrication. Before the hydraulic tools, this was the tool we'd use to open up doors, right? To break windows. And we don't smash windows, by the way. We just put pressure on them to break because you don't want someone to, you can pass it around if you want. Just don't swing it at anyone. Listen, I'm surprised security let me through. The only reason they let me through with that because they had no clue what it was. So, but yeah, you can pop tires with it. You can open up doors. There's a lot you can do with that. It's an all-purpose tool. It was actually developed by it was FDNY because they were went to a fire call where there was a bank robbery. And the bank robbers actually had their homemade tool like that they were using to pry into scuttles on the roof. So a firefighter saw that and he says, oh yeah, I can make that better. And so that's how that came about. So, okay, so we see, tow, they brought, after the winch didn't work, right, they brought in a tow truck, a heavy tow, to pull the vehicle out. And all they need to do is pull the vehicle out just a little bit, just so they can get access. You also notice that, and while I was talking, they probably cut the door, the passenger door off, right, the rear door off, as well as cut the B post, the post that sits between the front and rear door, right? So they cut it right here, right? So that's all things that we have to do. Next thing he's doing, he's cutting right here, cutting the seat, because now to get him out, right? If you can't lift the dash, what's the next thing we do? Move the seat back, right? Or lean him back to get him out. And once we get him out, then he goes in. So pretty, again, pretty complicated situation, but it's not uncommon. Again, like I teach extrication, and this is actually taken from the course I teach. Is all the skill sets. So the skill sets for stabilization, right? Stabilizing the outside of the vehicle, meaning, you know, keeping it from rolling, and stabilizing the inside of the vehicle, meaning keeping it from starting up again. The way we do external stabilization, or if we forget to do external stabilization, shit happens. This was actually, I believe, in Mexico. So. You don't want to ever have that happen to you, and you don't want to have people videotaping it. One of the rules in the firehouse is that assume you're being videotaped all the time. So our gallows sense of humor is usually quiet on the scene. Second is interior stabilization. Now, he's using the Halligan, right, to kind of open up the hood. And again, this is about a 1-minute video. Just open up the hood. Why do you think they're opening up the hood? Anybody know? Just to cut the battery. All this work just to cut the power, right? Do you think that resources could be spent better in actually tending to the victim, right? I can't tell you, when we teach extrication, how much time is spent, people can't get the frickin' hood open, right? And, you know, in my mind, when we're dealing with EVs and we're dealing with high voltage vehicles, there are voltage disconnects along many parts of the vehicle, so you can do that. But the 12-volt system is really not an issue anymore. The 12-volt system can actually stay energized. So even though I teach that, we say don't focus on that. If you can't get that hood open in 30 seconds, get to the victim. Let's get the victim out of there, because nobody's salvaging that car. It's basically a write-off. Second is EMS access, and that basically comes through. Let's get to the victim as quick as we can, and just we worry about spinal injuries. That's the #1 worry we get, and then we worry about all the other things that are happening. And then once we can get to the victim, we want to take out all the windows we can, just to, again, get more people leaning in and helping out. And then, of course, we worry about getting the doors open. So again, this doesn't have much sound, but they're talking about explaining how to stabilize somebody's neck. It's typical EMS stuff. Glass removal. And again, we look at all the different steps that it takes here. And yeah, a lot of it's manual, but again, what can we do to kind of make this better? Anybody want to be a firefighter yet? Nobody? No? Anybody want to stop driving yet? So if you notice, they're using a Sawzall or reciprocating saw. When I teach, I actually have my firefighters sit in the car. One crew sits in the car while the other crew is sitting on the outside. Why? Because that sound, and again, we can't hear it now, but that sound inside the car echoes. It's deafening. And if you're bleeding and you have a broken bone and you're waiting for somebody to pull you out, that is the scariest sound you can have, right? Same thing with the door opening. You're going to hear all these creaking and popping sounds from the spreaders, and you're not going to know what's going on. You're just going to hear metal ripping around you, and then you don't know what's happening. So again, keeping this in mind, we want to try and be as quiet or as smooth as possible. Just to give you an idea, you see this thing here? Anybody know what that's called? It's called a nadir pin or a staple. developed by this guy named Ralph Nader. Okay, I'm really aging myself now. He was a activist for car safety, and that's one of the outputs of his work, was to make sure that doors latch securely, because doors were opening up, kids were flying out, maybe on purpose, but the Nader pin is really, really difficult to get through. It's hardened steel. It's actually sometimes easier to cut around it than to cut through it. And then victim egress. And again, that dash roll, remember I said if the dash comes down on you, we can actually, there are techniques we use to roll it. Third door technique basically says take the front door and the back door and cut the posts in between. You make a bigger door opening. Roof removal. We use this a lot because if we have all the cutters out and we're cutting all the posts, let's just cut them all and get the roof out. That way we can get better access. And victim removal is basically packaging the victim. So this is called a ram. Ram is lifting up that dash, probably about 6 inches. You only need like 2 or 3 inches to get the victim out, but they're just demonstrating it. Problem with this is that this was in the way. Can you get the victim out when that's in the way? No. So we lift them, we freed them. Other interesting thing, when people have crush injuries, when you release that crush injury, it's very painful. So even though they're quiet, like I said, there's a lot of pain, they're quiet, then you release that blood into that system, then it gets loud again. So you don't want to be stuck having this open and all of a sudden not being able to get the victim out right away. Third door technique, and this is a little bit longer, but we're cutting the post. And this doesn't have a rear door, but we can make a rear door out of it. And if you notice here on the top, I have basically the total time to do each of these operations. These are average times. I've been to things that are shorter and things that are longer. I think the shortest extrication I've been to is probably a half hour, and the longest was probably without a fatality, with a live person, it was 2 to 3 hours. I'm sorry? Yes, we did a Land Rover the other day, and the Land Rover, so I'm not going to get into too much technology, but Land Rovers have something called ultra high strength steel, and that steel gets stronger when you compress it. So if it gets into an accident, it gets really strong. But the only way to open something is to, if you don't compress it and you try and stress it, it cracks. And so using spreaders to open up the door was just flaking off in pieces. We couldn't get a standard door opening on that Land Rover. And you can't cut it with a reciprocating saw because it's ultra high strength steel. Removal, again, something, if you've cut the B post and you've cut the A post already, you might as well just cut the last post, the C post, and just get the thing off, get yourself some access. So once that roof is off, right, it makes it real easy for access. And actually, on the more serious injuries, you'll probably have someone working the C-collar, working the spine, someone else working the legs, someone else working the abdomen area because crush injuries. So you want to try and get people in from all different angles, and this kind of helps out there. And a victim removal. So I'm not an EMT, and not an EMT for a good reason. I can't stand blood. Now, I've been to hundreds of accidents with probably the worst things you've ever seen. But I can do that for 20 minutes to get that guy out. I can't be in an ambulance, listen to him scream 45 minutes on the way to the hospital. So I'll do the packaging, but that's about as far as I go. All right. So the challenges, we talked about this, right? The ultra high strength steel. Cars have crumple zones in the front and back. The cabins are actually really, really well built. They have these ultra high strength steel, usually on the A post here, the B post, the rocker panel, which is the lower end, and the roof panel, right? I've been to car accidents where it was a Honda Pilot, it had a driver, mother, and 2 kids in it, and 2 kids were in car seats. They overcorrected. They were swerving, they overcorrected, they hit a rock wall on one side, and then it rolled into a rock wall on the other side. So the whole front of the car was taken off on the Pilot. The whole rear trunk area of the car was taken off on the Pilot. Unfortunately, the mother did not have her seatbelt on, and she was thrown from the car. She lived, but the two kids, car landed upside down. Two kids in their car seats, not a scratch on them. But the bad side of this is this ultra high strength steel can't be cut through. And if we try and use cutters or spreaders, right? The spreaders will fracture the metal, and the cutters compress the metal, but the cutters will fail before the metal does. So we have to we're kind of getting to a point now where actually cutting the car open is a hit or miss operation. And this is kind of where I started thinking about that software side of things. So this came from an idea that we have in the fire service. If anybody when you take an elevator, right, they have the little key on the bottom. It says fire service mode. And that's basically in high rises. When there's a fire, you want to have all the elevators recalled to a safe spot. And then you want to have a second mode where the firefighters can use the elevator for transporting victims, equipment. So this is where this came from. It's like, well, why can't we have something similar for cars? What can we save by doing this at the extrication level? So let's talk about stabilization. At stabilization, we can actually turn off the engine and all the accessories, right? Which actually happens today. Maybe we can engage the parking brake automatically, right? It's all software driven. It's all drive by command. Why not? Shunting fuel flow is actually on most cars today. That happens. The high voltage systems, some EVs will disconnect. And I also teach a class on EV fires. On an EV, your floorboard is that's the actual battery platform, right? So think about this. Everything that's like 700 volts. That's deadly. That's DC. When you get into a car accident, all the things that are run off that 700 volts, the transmission, the braking system, everything automatically disconnects. But the platform itself is still a live energy source. So think about that. So anyway, one of the other things we could do is maybe deflate the tires. Deflating the tires, even if we can't, if we're on a steep incline and the parking brake doesn't hold, deflating the tires will at least keep it from moving very fast. What about access? What can we do for access? Well, you saw with the airbag video, happens a lot. And we are very careful now when we enter a vehicle. We don't enter it from the sides. We try and enter it from the rear seat and deal with the patient on the front seat, all because of that airbag. So maybe if we could disable the airbags after a crash, not before, that might help. Maybe unlocking all the doors for us gives us a chance of opening up another door. Even if the driver's side door is crushed in, I can go through the passenger side door without having to break a window and try and reach in. Again, breaking a window all takes time. Maybe I roll down all the windows if I need access. If I had a way of just rolling down the windows, right? Maybe I can get access, put that C-collar on right away. And finally, maybe you have the rear door can unlatch now, right, in the hatchbacks and on the SUVs. Maybe if we had something like that, or maybe with the electronic doors, which have to have a manual handle override, exposing those handles, right, during a crash. So that way, someone who's in a panic can grab for something and actually feel something. And also, if I go up here, right, I've kind of estimated some time savings from all these things. Again, from a minimum to a maximum. Here's for access from 3 minutes to 20 minutes. And for egress. So we have that dash roll, right? And the dash roll only works if we're free. But so we always, our plan B is, take the headrest off, try and recline the seat, right? Plan C is actually spread the seat from the front and move the seat back. All software controlled because it's all electronic these days. Why can't we just do this? Right? Once we're ready to access the victim and take them out, why can't this just happen be a software command? So, and the fire control, we'll talk about that separately, but, if in EVs, I'll explain a little bit about EVs, right? The platform, that battery platform is the bottom of the car, is the undercarriage. It's really reinforced with usually 3/8 inch aluminum and has an airspace and then another sheet of 3/8 inch aluminum for crash protection and debris protection underneath. But they need to save money. So what do you think the thinnest part of that platform is? It's the top. It's the shroud between the top of the battery and the floorboards of your passenger cabin. So if an EV catches fire, which way do you think the fire is going to go? into the passenger cabin. So when we get to a car fire, first thing we do with a hose line is actually put it on what they call fog or spray, and we spray the cabin right away. Because at a fire, sometimes we don't even see the victim in there because there's so much smoke and so much fire. So we will go into the cabin with a hose line and spray right away and see what we have and see whether we need to pull someone out or we just fight it normally. Well, why not have that sprinkler system built in, right? Well, water takes weight and this design takes money. So fire retardant in the engine compartment, I've seen that in a few cars. They're usually little capsules that when they burn, they create dry chem. Work fairly well, but not always. And again, the EV battery platform is just an issue that's increasing. So I don't see any immediate ways we can deal with that. All right. So I've talked a lot about extrication and all the operations we do and some of the software that we use. But what's the real time savings? So again, if we're talking about an extrication taking 15 minutes, meaning you go in, you pop the door's open, you just seek out the victim and take them out. And to me, the worst case being 2 hours, that's probably, something a little more complicated. What kind of savings can we get? Well, we get anywhere from 5 minutes to an hour, right? 5 minutes is a lot, right? And even if all those things I said that we could do, we can't do. Say we can only do a quarter of them. If we can only do a quarter of those things, we'll save maybe 15 minutes. That 15 minutes, I mean, I've seen people die right there. And that 15 minutes could have maybe been the chance between them living or dying. So I'm really passionate about this. So how does this work? I think during a crash, right? It would automatically go into stabilize mode. When a crash sensor goes off, anything that can be used to stabilize the vehicle, that software should do, right? It's only software. Nothing fancy about this. Second thing, if I show up on the scene and I have my universal remote, right, the fire service key, right, that we have an elevator, something similar, maybe I could say, hey, press a button there. Now, if the crash sensor hasn't gone off in a car, it should do nothing, right? I don't want to be able to use this to disable a car that's already running or in good shape. But if the crash sensor did go off, I'd do the same thing that the automatic crash sensor would. Maybe I press another button and it says, hey, disable the airbags because I want access. Unlock the doors. If I can't open the windows, open all the windows, right? How many people have Hondas? So on a Honda, if you hold the lock button down, what happens? It rolls down the windows 4 inches, right? Just to let the heat out of the car. It's all software based. It's nothing big here. And maybe for egress, I automatically raise the steering column as my number one thing. And maybe if I need more room, maybe I can extend the seats and maybe I can recline the seats. All these things save time because I don't have to think about how to do them. Especially with electronic seats, you're not going to be doing it manually. You're going to need a tool like a spreader or a cutter to get that, and that takes time. And of course, if you have the capability of sending status signals back, you'd want to do that. In fact, this is kind of the way I envisioned it. You have a fob, and again, real easy for firefighters, right?
Really easy for me. Huh? So it's really easy for me too. Yeah.
So if I click stabilize, it's going to do all those things. Maybe send back some indicators, right? Egress, and then of course, if I do fire suppression, again, all cool stuff. But is it really going to work?
I don't know.
So anybody know who this is?
Hi. You probably don't because he hasn't given you a slide yet. I'm here to tell you, but wait, there's more. Because he comes from a fire safety background, and I actually come from a vehicle manufacturing background. So this is me. I'm Kat Seymour, but I'm Kat Delorean is my maiden name. My father's John Delorean. I kind of was born with gasoline in my veins. But I spent the past 20 years working at Bank of America in cybersecurity.
So, John and I worked together some time ago. And when he heard I retired from the bank after 20 years, and I wanted to focus on mentorship without going into the long story of how I ended up building a car because of it, Basically, I wanted to create an automotive engineering program and ended up with a car company. Fun story. But John heard me talking about death napalm and my thoughts on EV fires. And my father is huge on safety. He actually testified before Congress and is the reason why seatbelts are mandatory in your car today. You're welcome. So my whole life I heard about vehicle safety and growing up, like how we deal with it. So when he approached me with this program, I got very, very, very excited because it can really save some life. Just like he said, a few minutes can make all the difference in somebody's life. So John comes from a background of safety first and the rescue operations. And what that means is he's going to do it in the order he was taught. But when he asked me to take a look at it and bring it to some of my vehicle people, we started talking about some of the things that can be front loaded, how we can actually do this, leveraging some of the systems that are already there. So when you have the expertise, the first responders, they obviously have to follow things in a certain order because you have to make sure you stabilize the vehicle so the fire car doesn't go rolling down the hill, things like that. But when you talk about, so let's see, there, this front loaded. He switched the slides on me, so that's right, kind of a little. I'm doing it backwards again. So when we have the crash actually happen, in the order that John went, you had to start with deflating the tires and all of the things that actually stabilize the vehicle. And then you move to some of the things like rolling down the windows and unlocking the doors. So what happens if we actually can take care of all of this stuff in the beginning when it happens? Because what difference does it make if I got in a car crash and I unlock the doors? And I had to talk to John about this. So if I get in a car crash and I unlock the doors, it's not going to make any difference to the passenger inside. But if I get in a car crash and I say roll down the windows, it could, because you could be in a situation where, say, you're in a water landing and you don't want those windows open. So we had to talk about some of the things that would actually be more useful to front load. And some of the things that we actually talked about. So let's see. Many of the things that we're actually talking about now are pretty much standard on cars, and they have been for some time. For instance, the DMC-12 back in the 80s had automatic unlocking doors because my father, again, obsessed with safety. And this is something that he saw the potential for. He didn't develop the seatbelt. He fought for it like adamantly. And then, so when he retired from General Motors, which was 50 years ago, I think like today, isn't it? Yeah, something like that. Interestingly enough, he was fighting with them to implement seatbelts and airbags and things like that. And it's obviously very expensive. We'll get into why some of these things can't be implemented or won't be by automotive manufacturers because of the minor cost. But he got a little upset. And when he retired, he was hired by Allstate, which is actually where the car came from. Interesting tidbit for all of you in here. The DMC-12 was originally designed as a safety vehicle designed for Allstate to come up with something that was a lot safer. So he then got his revenge, I suppose, by going and testifying before Congress for Allstate that seatbelts will save lives, and now they're mandatory on all the cars today. So that's where that comes from. But some of the things too that we have that are listed here, they're going to require changes to the actual structure of the way that things work. For instance, installing the fire suppression system, but others already exist. So if you have rolling down the windows in your car, if you might have a key fob already that you push a button, you hold it, and it rolls down your windows, or it can roll up your windows. So that's a feature that's already got software, that's commands that are in there. When we're talking about things like that, we can actually make the changes without what's called a 50,000-mile road test. So when you make changes to anything on a car, if the car has already been what's called homologated and basically safety rated and approved for driving on the road, if you change anything at all, you have to go through what's called a 50,000-mile road test. And this is a test where you drive the car for 50,000 miles and you test out certain situations, and you're going to have to meet each situation, you know, having the car do certain things, going uphill, things like that. And what's crazy about this 50,000-mile road test is the way Malcolm Brickland, who I'm working with now, put it. He said you can go 49,999 miles, and on that last mile you hit a squirrel, it's all over. You got to start over. So when we're talking about making even minor changes to automobiles, it's a huge cost to the auto manufacturer. Not only because of the cost of the test itself, but any little change will cost a lot of money, and we'll get into that in a second. So when you're talking about something like automatic engagement of the parking brake, this could be something that I couldn't get a clear answer on this one from my team yet, but automatic engagement of the parking brake is something that could have impact to you as a driver. Driving down the road, parking brake goes off and you're in trouble. So this would be something that they would want to retest because they want to make sure it doesn't happen when you're randomly driving down the road. And then something like self-deflating tires. This may actually require a full crash test engagement because, again, you don't want these tires deflating at the wrong time. You have some interesting options when it comes to tires that can run flat and things like that. But this would be something that would more require a recertification of a full crash test. And then I actually asked about this one, and this one's really interesting. So disabling the airbag triggers would require vendor support, and we all love vendor support. So this would actually require us to go to the airbag vendors and have the regulations changed, because anything that deals with airbags is a regulation. And it seems like such a simple thing, because the airbags are disabled. The problem with that crash that we saw, the airbags are disabled because nobody's in the passenger seat. And then the car gets into an accident. The airbag is still active. So you put the pressure on the seat and suddenly the airbag inflates. So it would be just as simple as having it not re-engage after you got into the accident, but we don't have that. And then again, it's something that it sounds really, really easy to us. Just change the code and it doesn't engage after an accident. But there's all of this testing and cost that goes into it, and it's not just the cost of the code change. Some of the things that we talked about too, like the automatic reclining of the driver's seat and the raising of the steering column. So John was talking a lot about Checco. Sorry, you're going by Checco. Was talking a lot about how you're really focused on the passenger stabilization, their neck, their back. Obviously, you can't do these things unless you, one, know the position of the passenger, because if you raise or lower the steering column like onto their lap in the situation we were watching the video for, that's not really going to work. You're going to trap him more if you lower it into his lap. So you want to make sure that the firemen actually have control over what happens here, because they need to stabilize their victim first. So this is where we start introducing things that have to be done manually as opposed to automatically. You want some control over it. And then here, so I asked my dad had me write a book once for him called the GM Repair Manual. And in this book, he talks about that when they started Saturn. Anybody in here remember Saturn? Yeah, okay. So back in the day, instead of fixing what was wrong with their existing product lines, General Motors said, let's go ahead and start a whole new car company. How many people in here didn't know Saturn was GM even today? Yep, so that's not uncommon. They very, very, very specifically wanted you to not know that, instead of investing into the quality control of their other cars. So he put in this book, he said, if they would invest 25 cents more for the interior on the work truck, it would last the lifetime of the truck and increase customer satisfaction. As it was, we were buying work trucks, and after 2-3 years of steady use, the truck was fine, but the interior was trash. So I said, why? Wouldn't they just put 25 cents more per truck? It's 25 cents times millions of cars is a lot of money. And that stuck with me forever. So every time I think about all the things that John's asking about, I think 25 cents times millions of cars is a lot of money. Now, you and I may think logically and go, why not just raise the cost of the car 25 cents? It doesn't make sense to me, but, hey, capitalism. So that's why something like this, I don't think is going to get made by anybody until they actually mandate it. Now, this is something that our car company is actually working on. I'm not a traditional car company. We're going to fund public school education, and we're going to actually invest in safety research like this so that we can prove that these things work. But when we talk about these, again, it's really important to remember it's an uphill battle. Capitalism, cost, all of these things. Public speaking, it's just wonderful. One of the interesting things we can do for a fire control system, though, is to think about alternative methods that we can offer people. Like, what if you just sold a Tesla with a fire extinguisher that could put out the fire inside? Well, an accessible handle would be nice, but let's just go ahead and say something is simple. And so we need to also think about some of the easier ways that we can solve some of these problems. So we go into the software controlled issue, and we talk about some of the issues. Oh, 5 minutes that come up. So I lost my train of thought because he gave me the 5-minute warning. Possible kill switch. So a kill switch actually would be a really great solution. So anybody in here, if you like your car, install a kill switch. It is the most amazing anti-theft device. So good, I lost my keys once and couldn't get back into my car because the locksmith couldn't get in because I had the kill switch engaged. So you could actually have fire service mode, engage a kill switch, which would do all of the things like turning off the voltage and things like this, and be able to actually secure the car so that we can do all of the steps that we need to do. And then we talk about, and this is probably your slide too, right?
Yeah. So yeah, we talked about CanBus and being able to deal with that person going through the changing, pulling the sensors. Well, why couldn't we just encrypt the CanBus, right? And it would be encrypted by either TPM chip or maybe the fob that goes on the car. And again, during crash mode, that encryption falls back to unencrypted.
Yes.
That way you can have universal access. And that's kind of the whole point here, is that it doesn't take much to have encrypted communications.
No, but the issue with encrypted communications is you would then be forced to go to your dealer to get your car serviced. So the challenges remain, when it's the balance we always play, security versus usability, right? And so that's the challenge we have. But I think together we'll be able to actually make this work really cool.
So, any closing thoughts? Or?
No, I think I just gave them.
All right. So if we get back into the cybersecurity world or the software world, you think about, I'm a big fan of Sunil used Cyber Defense Matrix. This is how we use it in our SOC, right? How we use it in our organizations. Can we do something similar for the automotive industry or the rescue industry? And I stole from that a little bit, but instead of, identify, protect, and defend, maybe we have rescue as one of the columns. And what are we doing today? Well, protect, we have these things that are already in the cars, and we just add this. And that's kind of where I want to go. I want to, again, a lot of this is going to be software based. It's not technical. It's just basically software update. But again, with the legal, political, and other aspects, it becomes an issue. So I will open it up for Q&A. I mean, I know that was a lot of information and probably not too technical, but you in the front.
Just like we were talking about, you might make a modification to your car for fuel efficiency, etc. So could people choose to after-mod CanBus software to enable this if they wanted to?
There's a difference between you modifying your car and me modifying your car.
Okay,
right?
So me as the owner,
Yeah.
I'm able to do that, taking all the liability on myself.
Basically the same as jailbreaking your phone, right?
Yeah.
Right. But still there's a problem of that standardization and then making that available to the buyer.
I think one of the things we talked about early on was, can this be used to steal a car, right? And the whole idea is that it's a degradation only type of aspect, meaning that once you engage fire service mode, that car is a write-off. So that's saying if someone actually were able to fool the system and make it go into fire service mode, it's done, right? So there's no motivation for someone to steal the car that way.
Yeah, you'll kill switch the car. It's not going to move.
So the neighbor car.
Well, yeah, you can break your neighbor's car, yeah, sure.
Yeah, yes.
Well, of course, can regulate the switch that activate after a crash, and then you also human behavior is like stand on steering wheel for a set of 20 seconds, and human behavior also is like heart rate is above. Then maybe you could say, all right, activate kill switch after these things.
Yeah. Artificial intelligence and combined trigger.
Yeah, like looking at human behavior is also like what's accident looks like. Or even like head not on headrest for end of 20 seconds, and hands on steering wheel, hand is not there. Bam, activate kill switch firefighter.
I mean, OnStar has some pretty cool things that they do, right? Even if you have OnStar, you never paid for the subscription. If you get into a crash, they still get notified.
Yeah.
So, yeah, I think it's just a matter of what you do afterwards and how you do it is important. Yes?
Have you looked into, like, in how many of these crashes would these systems still work, or would it CanBus systems still be operating?
So I showed early on that we opened up the hood to cut the 12-volt system, and I said that in these days, 12-volt systems really don't cause fires, they don't cause issues. So I would say you do the high voltage disconnect for EVs and hybrids, so keep the 12-volt system running. And how many of these systems still work? We've had cars fly off the embankments into trees, with the headlights still on, even after we cut the 12-volt system. A lot of these systems have 2 or 3 batteries now.